Here we're going to be looking at a very specific application to linear functions. It's a business application involving supply and demand, okay? And first I want to get out of the way some vocabulary terms that we're going to be using. When we talk about quantity supplied, we're talking about, in a business scenario, the amount of product a company is willing to make available for sale at a given price. How many items how much inventory do I have to sell when I'm selling something at a particular price? The quantity demanded is going to be the amount of that product the consumer is willing to purchase at a given price, right? Typically, how much is sold is dependent upon the cost of the item. Typically, you would think that the greater the price of the item, the fewer units you're going to sell. Then we have equilibrium price. It's the price at which your quantity supplied equals your quantity demanded. And this is really important. You want to figure out your equilibrium price so that you don't end up with any excess inventory, right? You don't want to have, you don't want to make more than you are able to sell. And then that comes down to the equilibrium quantity. It's the amount demanded or supplied at that equilibrium price. So how many units do I need to sell in order to match that equilibrium price? Okay. So here is a very, very sophisticated example involving supply and demand. Selling hot dogs at a baseball game. Okay. I have two equations here. I have a supply equation and a demand equation. Okay. Suppose the quantity supplied S and quantity demanded D of hot dogs at a baseball game are given by these two functions. So S of P is equal to negative 2,000 plus 3,000 P, and D of P is equal to 10,000 minus 1,000 P. So P is the price per hot dog, and then S of P and D of P would represent quantities, okay? The quantity supplied, the quantity demanded. So we want to know what's the equilibrium price for hot dogs at our game. Okay, what's the equilibrium price? What should we sell these hot dogs for so that I don't have any leftover at the end of the game? So basically what I'm trying to figure out here is when is the quantity supplied equal to the quantity demanded, at what price? Okay, that would mean I'm solving this equation. Negative 2,000 plus 3,000 P is equal to 10,000 minus 1,000 P. Variables to one side, constants to the other. So 4,000 P is equal to 12,000. P is going to end up being 3, and that would be $3. So basically we're saying we need to sell these hot dogs at $3 a piece in order for me to not have any leftover at the end, okay? Part B, what's the equilibrium quantity for hot dogs at the game? Equilibrium quantity. Well, if we go back and look at our definition, equilibrium quantity is the amount demanded or supplied at the equilibrium price. Well, we just found that equilibrium price to be $3. So to find this equilibrium quantity, we could find S of 3 or we could find D of 3. It doesn't matter. You could plug the $3 into either function and it's going to result in 7,000 hot dogs. Okay, so we got to sell 7,000 hot dogs at this game. Now, part C, determine the prices for which quantity supplied is less than the quantity demanded, right? Solve when is quantity supplied less than quantity demanded. We're essentially going to be solving the same thing that we did in part A, except instead of an equation, this is now an inequality. We will end up with P is less than $3. Okay. All right, so think about what that means in the context of this situation. Your quantity supplied is less than your quantity demanded. Your quantity supplied is less than your quantity demanded for any prices less than $3. So basically, we're saying don't sell these for any more than $3. Otherwise, you're going to have extra left over. Okay.